Hello and welcome to Pradeep Sir classes as PSC, and this is the Numerical King series, that is H.C. Verma solutions. And today we are going to discuss Gauss's law from question number 1 to dash, that is to be continued up to 24. So all the numericals I completed with a deepest concept. So follow, and first of all take your copy pen and as well as H.C. Verma book, and if it is not with you, then you can download a particular PDF or buy it. It is so available book. So let's start with question number 1, and you can follow, students. This is the Numerical King series, and there is another series, that is H.C. Verma. That is Erudov classic text series. And if I suggest you, there is those who are JEE main or advanced or NEET aspirants, and they can follow. But if you follow that, if suppose you can't realize that particular numericals, and then it will be profitable for you, because there is a particular specific explanation of the numericals that will help you. That is, suppose first of all there is a numerical related with Coulomb's law, and here what is the vectorial form of Coulomb's law. I explain all the concepts and then I do the numerical, so that's help you. Okay, so let's start with Gauss's theorem, and the numerical is numericals. Yes, it is in 141 page. So first of all, students, question number 1, that is the electric field in a region is given by E vector equal to, electric field E vector equal to 3/5 E naught I cap. I cap is a unit vector along x-axis, and 4/5 E naught j cap, and 4/5 E naught j cap. So the electric field in a region is given by this one with E naught. With E naught means I is given with the value of E naught, and that is 2.0 into 10 to the power of 3 Newton by Coulomb. 3 Newton by Coulomb, and you have to calculate flux through a surface area. Through the surface area, the magnitude of this area is given here, and it is 0.2 meters square. And this is also a vector E magnitude. This is E magnitude. Its value is, so it is the magnitude of this value is this, and area vector is 0.2 meters square. 0.2 meters square. And you have to find flux phi through a plane, parallel to YZ plane. So the question is question number 1 is a electric field equal to 3/5 E naught I cap plus 4/5 E naught j cap, where E naught equal to this one, and the surface area is given, and you have to calculate flux through a plane that is parallel to YZ plane. So students, first of all you have to know what is a space vector. That is, electric field is given here. So what is a space vector? And suppose if I give a question, what is the basic difference between a dictionary and this particular book, that is physics book? What is the basic? Similarities and dissimilarities. So you can say easily that is the similarity between the dictionary and the AC Verma is there are different alphabets, A, B, C to Z, A to Z. So this is the basic similarities. But if I say what is the dissimilarities between them, then you can say that the arrangement of the alphabets. The arrangement, due to that particular arrangement, this is physics books, this is dictionary, this is chemistry book, this is one, and all the books contains the alphabet that is A to Z. So that's why if we say what is the electric field, or it is a what is a field vector, then you can say that it is the arrangement of this one, like that. Suppose E vector equal to 2 I cap and 3 j cap, and if another boy take a different vector E2, this is equal to 3 I cap plus 2 j cap, then the arrangement is different for that particular electric field. So this is a vector space and this is a vector space. That's why you have to realize that the components of the electric field are arranged in different pattern. And if we add another component, that is this is 2j cap plus 5k cap, then this is a specific vector which is different from that and that one. So it is a space in which a different direction there is a component of electric field, means electric field intensity, it may be different. Okay. So this is a electric field is given, that is along x-axis the magnitude of this, and here it is written as 3 by 5 of u0. That is, this is the peak value of the electric field. So the peak value 3 by 5, 3 upon 5 into total, that is the peak value of the electric field, and that particular component acts along x-axis, and 4 by 5 of E0 along y-axis, but there is no component of Z that is along k cap, that is along z-axis. So first of all you have to do a figure. First of all, students, for each and every numericals, first of all realize that one and figure out that particular numerical. So x, y, z, x, y and z are the three axes, and according to this space vector, a component of electric field, this acts along x-axis. That's why I can write here as, this is the representation symbol, and this is E vector along x-axis, x component, and there is another component of electric field that is acts along y-axis, but the magnitude is greater, so I represent it as, suppose for my realization, you can write along this direction. If you take 2 arrows, then you can take 3, 4 arrows, that is the magnitude is greater. If you take along this 3 direction, then you can take here is 4. Suppose as for realization, more greater conceptual realization, so this is, there is two components of electric field. Is that clear? I think you realize the facts. And there is a surface area of 0.2 meter square in that particular plane. So this plane is given, that is 0.2 meter square. And we know that each and every surface vector is a specific unit vector related to this. That's why the area is a vector. Area vector equal to magnitude of this area and a outward normal that is taken for that particular vector. You have to take along this direction or along this direction. So this is n cap. So this is n cap, because so the area vector is area vector equal to 0.2. This is the magnitude. And n cap, here n cap is along x-axis, that is I cap. So 0.2 I cap is the area vector, And the question is that what is the flux? And from the definition of flux we know that how many electric lines of force can penetrate that particular surface. How? The number of electric lines of force that penetrate the particular surface, that is the flux. So for that particular contributions of electric field, the contribution of flux is due to the x component. But if you imagine that this is the surface and all the electric field lines are moving along that particular direction, can penetrate this one, and if it is along this direction then it cannot penetrate that particular surface. That's why the component of flux is coming from that component. So flux means the number of field lines crossing that surface, So it is so simple, that is flux equal to E dot S. E dot, suppose here it is A, so E dot A, and the electric field is given and the area vector is given, so multiply I cap dot I cap equal to 1 and J cap dot I cap equal to 0, so multiply this one and this one, so 3 by 5 E naught into 0.2, and the unit of flux is Newton by Coulomb, that is electric field, and meter square, that is surface area. So electric field and surface area, that is flux. So 3 by 5 E naught, and E naught is given, so multiply this into this into this. So the answer is 3 by 5 into E naught. E naught is given, E naught is 2 into 10 to the power of 3, 2 into 10 to the power of 3. So E naught is 2 into 10 to the power of 3 into 0.2. So 2 to the 4.4, 3 to the 1.2 divided by 5 into 10 to the power of 3, and this is 5 to the 10, 5 to the 10, and 5 4 the 20 into 10 to the power of 3, that is 2.4, that is 2.4 into 10 to the power of 2 Newton meter square by Coulomb. But the answer given here 2 to the 4 0.2 sorry 0. Yes, 0.2 meter square is given, so 2 to the 4 and 3 4 is 12, 1.2 by 5, so 5 2 is 10 and 5 4 is 20, that is 2.4 into 10 to the power 2. Yes, the answer is correct. So 240 Newton meter square by Coulomb, or you can write that particular. Okay, so the answer is correct, and we go for the second numericals. The second numericals is the charge Q is uniformly distributed. So question number 2. The question number 2 is a charge capital Q is uniformly distributed over a rod of length. So a rod is given, a rod of length L is given, and Q charge is distributed through Q. There is Q amount of charge is distributed here. Okay. And a charge capital Q is uniformly distributed over a rod of length L, and consider a hypothetical cube. You have to consider a hypothetical cube. So a hypothetical cube, x, y, z axis, Yes, so this is a hypothetical cube. And you can take as dot 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 since this is hypothetical. So this is a hypothetical cube of length. Hypothetical cube. A charged capital Q is uniformly distributed over the rod, and consider a hypothetical cube of edge L and cube of edge L with the center of the cube at one end of the rod. Find the minimum possible flux of electric field through the entire surface of the cube. So students, the numerical is, you have to realize first the numerical one. A length L of rod is given and capital Q charge is uniformly distributed, that is vital point. If the charge is non-uniformly distributed, then you cannot calculate what amount of charge is contained within half or within 1/4 of the length of the rod. There is L length of rod is given and Q charge is uniformly distributed, and that particular rod is introduced in such a way that the rod just touches that particular center of the cube. That is center of the cube. This is that one, and this is the rod of length L. So rod of length L and the edge of length L, rod is also L. That is the main point. The length of the rod is same as that of the length of the cube. So students, first of all, you have to think that how much amount of charge is confined within that hypothetical surface, because Gauss's theorem states that phi net is equal to Q by epsilon naught. Sorry, Q inside by epsilon naught. Net flux equal to 1 by epsilon naught times net charge, or summation of charge, you can write charge enclosed within that particular hypothetical surface. So net flux, Gauss's theorem states that net flux is equal to 1 by epsilon naught times net charge enclosed within the surface. If you find how many charge are enclosed within that particular one, then you can easily say that what is the amount of flux generated from that particular hypothetical surface. Okay, and so the answer is so simple. And if that particular rod touches that one, then the enclosed portion of the length is half of this, L by 2. That's why the charge enclosed charge, so enclosed charge equal to capital Q by 2. Enclosed charge, that is, here it is Q inside equal to Q by 2. So the flux equal to Q inside by epsilon naught. That is, Q inside is capital Q by 2 into epsilon naught. So the answer is given. It is so simple numericals, but the concept within that particular numericals is, I think, it can clicks your concepts. So the question number 3. Next question is question number 3, and it is, I think you enjoy the numericals. Question number, and if you enjoy, then what to do? Subscribe my channel and clear more and more concepts I explained. And question number 3, show that you have to write down that particular question. It is more conceptual. So that there can be no net charge. There can be no net charge. There can be no net charge in a region in which the electric field in which the electric field is uniform the entire surface of the cube. Oh, that's the problem with shock. So students, when restrictions comes into play, then just take aside that particular one and then continue. Okay. And the entire surface of the cube. Okay. So the entire so that there can be no net charge in a region in which the electric field is uniform. Sorry, student. Oof. And in a region in which the electric field is uniform at all points. Okay. So the answer, first of all, students, so that there can be no net charge in a region in which the electric field is uniform at all points. Suppose, first of all, I realize the different concept, you can establish an electric field with this is like that, a diverging ones. So you can say that the charge must be remain at that particular position. But if it is in converging nature, then you can say that the charge is also here, but the nature of this one is, this is positive and this is negative. And if it is uniform, then you can say that this is like that. So if we take small area at a particular position and a small area along that one, then is it a parallel? Is it a uniform electric field? No, this is not uniform electric field, because the divergence and converging field can't produce electric field. So diverging and cannot uniform electric field. That's why like that. So it is diverging, it is converging. So converging and diverging character of electric field cannot produce uniform. So this is an approximation. What is the approximation? Suppose there is a charge and electric field lines just like that. You can represent with her arrow. And students, if you take a small area here and here, then the electric field intensity is different. At that point it is maximum, and that point it is with respect to or comparable, and this is greater than that particular position, electric field intensity, and it is measured with respect to how many electric lines of force can penetrate that particular surfaces. So if we take a small area at any one places. Suppose if you take a small area at that places and take another small area at that places, you can and take here also. That is, the area must be taken within a small region. If we take a small region, then it looks like that one. If we take a total, then it is like that one. So it is an approximation. Electric field is uniform. That means it is taken within a particular region, and when we take a particular region of this field, then charge doesn't exist at that point. The charge remains at a distance apart, that is at a particular distance from that region. So you have to prove that one. There is no charge within a particular uniform electric field, and the charge exists somewhere outside that particular region. So with the help of Gauss's theorem, we can easily show that particular character. So with the help of Gauss's theorem, we can show that particular character. Suppose this is a uniform electric field. And if we place or consider a hypothetical cylinder, suppose you have to just imagine, there is not the actual case, you have to imagine this is a uniform electric field and a cylinder is kept within that particular uniform field. So this is the surface area and its outward normal is along this one, so you can take is minus n cap, and this is take, you can take n cap. So this is in opposite direction. But if we choose a particular surface at that one along on the curved one, then it is also, suppose it is n dash cap. Okay, take a small portion of area. So if we suppose you think that there is a charge within that particular cylinder, so you have to take electric field is here along that particular direction, so you have to take the contribution of all flux comes from that particular surface and that part. For that particular curved surface there is no flux. Flux means how many electric lines of force penetrate that surface. So if you take a closed integration, there is total flux, net flux equal to net flux for that particular surface. Net flux means what is the amount of flux that is entering the particular surface, what is the number of flux that is leaving that particular surface. Enclosed flux, what is the enclosed flux? So flux equal to, you have to take closed integration of E dot ds, that is by the definition of flux. So E dot ds closed integration means that particular cylinder are formed with a particular circular one, and this is also circular, and this is a curved surface. So three surfaces are there within that particular cylinder, and surface 1, this is 1, and this is 2, and this is 3. So there are three surface, this is curved one. So you can break this integration, closed integration, into a open integration. There is open integration 1, that is E dot ds, plus open integration 2, that is also E dot ds, and the open integration 3, that is also E dot ds. Okay. So the contribution of flux, you have to think the electric field, direction of the electric field. So this is electric field. So if we take a unit vector along that particular direction, then E vector equal to E into r cap. So for the first one, so for the first integral value, first integration is E ds into r cap dot n cap. First integration. Sorry. E dot ds, first integration, this is r cap dot minus n cap. And here r cap is along n cap. So you can write here in place of r, you can write n cap. So this is n cap dot n cap. N cap dot n cap plus the second integration, that is EDS and that is the n cap dot n dash cap plus integration this one, so integration of EDS and n cap, so n cap dot n cap. So students, first of all you have to realize the unit normal vector. Unit normal vector is a vector that only suggests the direction along which that particular physical quantity changes. There is the electric, it may be electric field, it may be the outward normal, there is along x-axis, y-axis, z-axis, or the surface unit normal. It may be. So EDS n cap minus n cap. So n cap dot n cap means 1, and in this is minus 1, so minus 1. So the first integration will be the first integration is if we take the whole surface, and this is a small portion I take, so that particular one, if total surface or if the cylinder is with a bigger one, then the integration of ds is es and it is negative, es and it is negative. So this is a small portion and this will be the whole portion, and this is minus es plus 0, since this and this are 90 degree, so this is 0 plus of es. So es and es cancel this one, that is 0. So the net flux phi net equal to 0. It means that when the electric field lines penetrate that surface, the amount of flux, since this is uniform, if students, if it is not uniform electric field, that is like that, then the entering flux is not equal to the outgoing flux. But since this is uniform, so the number of electric lines of force penetrating that particular surface is looking for that particular one. So E minus of EDS, this is equal to 0, phi net equal to 0. That is the net flux enclosed within that particular surface is 0. That's why if we apply phi net equal to Q by epsilon naught, that is Q inside by epsilon naught, the last point. So the last point is phi net equal to Q inside by epsilon naught, but this is equal to 0, so Q inside is equal to 0. So there is no net charge enclosed within that particular cylinder, and it is proved with the help of Gauss's theorem. So students, next take the next numericals, and it is also more conceptual, and most of the year it may be joint NEET or board exam. For the question number 4 is very interesting and conceptual, and it comes in exam frequently. So the electric field, question number 4, the electric field in a region is given by, the electric field is given, so electric field equal to E naught x by L, E naught x by L, and this is I cap. So electric field is given, find the charge content inside a cubical volume bounded by the surface x equal to 0, comma x equal to a, then y equal to 0, comma y equal to a, and z equal to 0, and z equal to a, and E naught is given, E naught equal to 5 into 10 to the power of 3 Newton by Coulomb, and the length is 2 centimeter, and A is given 1 centimeter. Okay. The electric field in a region is given, and find the charge content inside the cubical volume. Charge, what is the amount of charge content within that particular volume bounded by that surfaces? Okay, so the first of all students, you have to, as I say, you have to realize the first step. Yes, so this is first step. Step number 1. Electric field is equal to E naught x by L. L is a fixed value. L has a fixed value, and E naught is also given. E naught is also given. So this is a constant. So E vector contains 3 parts, that is E naught by L, this is constant, and x is a variable portion, and I cap, you know that electric field is directed along x-axis. So the electric field, so the analysis of this line is electric field acts along x-axis. It's clear from that and that one. But is that particular electric field is a constant value or not? Then the answer is not. The electric field is not constant, because the E naught by L, it is constant, but there is a variable x. So if you place here as x, you can take x as 1, then the electric field is E naught by L. But if you take 2, then E naught. That means the electric field is increases along x-axis. So this is the vital point. Electric field increases. Electric field increases along that particular along x-axis. Yes. And there is a cube. And the next point is, so the electric field is changes along x-axis, and you have to figure out the numericals like that. So there is a cube. So student, this is a cube, and you have to draw that particular cube like that. So x equal to 0 and x equal to a, that means this is a, and y equal to 0 and y equal to a, that means this is also a, and x equal to 0 and z equal to a, that means this is also a. So it is a unit cube, and the volume is a cube, and the surface area, each surface area is a square, each surface area. So this is the second part, step number 2. And the electric field is increasing along x-axis. That's why you have to take like that the electric field is changing along x-axis, and like that. You can think like that, but it is not correct actually, because student, the electric field, if we place here x equal to 0, then the electric field is 0. So at that particular point electric field is 0, but I write down like that, so it is not correct. It is like that. Charge is somewhere within the cube. Charge is somewhere within the cube. That is the main point, and you have to calculate the charge. What amount of charge is enclosed within that particular cube because of the flux generated. So you have to calculate the net flux. So flux equal to and the flux is along x-axis, and for y and z axis it is 0. So there is no flux along this one or along that particular direction. So all the flux are due to the contribution of this surface. So first of all, calculate the net flux for that particular surfaces, because that surface there is no flux, there is no flux, there is no flux, there is no flux, and for the along that particular surface there is no flux, and the charge is enclosed within the cube. So like that, there is a cube and there is a charge inside it, and the flux generated is, and the contribution of flux is due to a particular surface, that is this is the YZ plane. So YZ plane, parallel to YZ plane. Okay, so for that one, the number, how many electric field, so the flux equal to E dot S or ES cos 0 degree 1, so E dot S, and the electric field is given, and the surface area is A square. So the surface vector is A square into I cap. So A square into I cap. So flux equal to ES, and E is E naught x by L. E is given E naught x by L into A square. I cap dot I cap means 1. So the E naught is given, and E naught is here. E naught is 5 into 10 to the 3. So 5 into 10 to the power 3 E naught into x. X means it is the distance of a, so this is a divided by E naught x. X is a and this is a square by L. L means L equal to 2 centimeter. So this is 2 centimeter. 2 centimeter. Yes, it is 2 centimeter. So 5 into 10 to the power of 3 into a. A means 1 centimeter. So 1 divided by 100 whole cube divided by 2 divided by 100. So this is the answer. So 5 divided by 2, 5 divided by 2, that is 2.5, 2.5 and 3 and 2, 5, and this is 10 to the power of 5 divided by that is 3 and 2, 5 and 10 to the power of 100, 100, 100, 10 to the 6. So this is 10 or 0.25. So 0.25 is the flux, that is Newton by Coulomb into meter square. So 0.25 Newton by Coulomb into meter square is the net flux. So charge equal to phi equal to Q by epsilon naught, Q inside by epsilon naught. So Q inside phi, that is 0.25 into epsilon naught, that is 8.85. So Q inside equal to 0.25 into 8.85 into 10 to the power of 12. 8.85 into 10 minus 12. This is Newton by Coulomb into meter square. So this is the answer, and you can generalize this one. You can generalize this one and get 2.2 into 10 to the power minus 12 Coulomb, and the answer is 2.2 into 10 to the power minus 12. Oh, sorry, Q, sorry, this is Coulomb, so this is Coulomb. So 2.2 into 10 to the minus 12 Coulomb. Charge is enclosed within the surface. And the next one is, so students, I think you realize that numericals realization is more vital. So question number 5. Question number 5. A charge capital Q is placed at the center of a cube. Find the flux of electric field through the 6 faces of the cube. This question is also a vital concept. Now all the numericals students, I think it is a very much conceptual from AC Verma. So please follow AC Verma and clear your concepts more and more stronger. A charge capital Q is placed at the center of a cube. A capital Q charge is placed at the center of a cube, and find the flux of electric field through 6 faces of the cube. So you have to calculate, if you have to calculate, there is a charge within the cube and you have to calculate the flux through 6 faces. Through field through the 6 faces of the cube. 6 faces means the net flux generated. Since you have to calculate the net flux. If the question is given, what is the flux generated through each surface? Not, it is 6 surfaces. So when 6 surfaces means net flux. So net flux equal to Q by epsilon naught. So this is the answer. But if it is given what is the flux for each surfaces, then you have to multiply it with you have to divide it with 6. So then flux each equal to 1 by 6 Q by epsilon naught. But for that numericals, this is the answer. Q by epsilon naught. Q by epsilon naught. And question number 5 is Q by epsilon naught. So next question is question number 6. Question number 6, and the students try the another numerical. This is the last one. Question number 6. So there is a surface is given here, and it is a, and it is also A, and this line is A by 2. So the question is, a charge capital Q is placed at the distance a by 2 above the center of a horizontal square surface of edge A. So this is a square. So this is a square surface, and at a distance a by 2 from that particular surface there is a charge of capital Q. Find the flux of electric field through the, so you have to calculate the flux generated and penetrate that particular surface. So you have to calculate flux for that surface, flux for that. So this concept is called symmetry. Symmetry argument. What is symmetry argument? Suppose, students, there is a charge at the center of the sphere, then the flux through that particular total surface is Q by epsilon naught. If the charge is given at that particular point, then net flux doesn't change. But you realize that if the charge is here, then the flux density remains greater at that particular region. Very close means intensity is greater. At a particular distance, the intensity varies. So this is not symmetrical position. So the symmetrical position is here. And if a charge is given a hemisphere at that particular position, then the flux you cannot calculate or apply Gauss'S theorem. But if the charge is given at that symmetrical one, then you can say that the total flux is half of Q by epsilon naught. That is, the net flux is Q by epsilon naught. So half of Q naught, you can explain or you can signify that one when the charge is at symmetric position. So if a charge is given at here and the surface is not closed, but you can apply, or you can apply, it is not correct, but you can say that the flux is half of Q by epsilon naught from the symmetry argument. Since if the total sphere is given and charge is enclosed within the sphere, then it is Q by epsilon naught. So this is half Q by epsilon naught. And the next one is that particular question. So imagine a cube. Imagine a cube and think the charge is within the cube. Yes, it is within the cube because it is a by 2. And the charge is within the cube. It is correct. The charge is within the cube. But is the charge is at a symmetric position or not? Then the answer is yes, it is at symmetric position because this is A and this is A by 2. So this is A by 2, that is, the charge is a particular symmetric position, that is at the center of the cube. So that's why the total flux or net flux equal to Q by epsilon naught. But the answer is not, the question is not like that. Question is that you have to calculate electric flux through a particular surface. So the flux through each surface is 1 by 6 Q by epsilon naught, and this is the final answer. So this concept is called symmetry argument. And there is another question you see, the question number 8. The question number 8, I think you have cleared up to 10 easily. Then 11 is something different question, and so try and continue your study and wait for the next class. And so I completed 1 to 6, okay, and the next day will be from 7. So thank you, and last of all I say continue your study.